Did you know that the James Webb Space Telescope requires a constant temperature of 370 degrees Fahrenheit to operate properly? Let's be honest for a moment. The James Webb Space Telescope is one of the greatest technological achievements ever created. It's a very sophisticated telescope that operates in orbit and transmits data down to Earth. Prepare to have your mind blown by some unbelievable facts if you've been wondering what all the fuss around the James Webb Space Telescope is about. The James Webb Space Telescope bears the second administrator of NASA's name. The James Webb Space Telescope was renamed in 2002, to James Edwin Webb's honor from the Next Generation Space Telescope. In his capacity as NASA's top official from 1961 to 1968, Webb transformed the agency from a disjointed group into the well-oiled machine it is today. Along with the majority of the Apollo projects, Webb also managed the Mercury and Gemini programs. The naming of the James Webb Space Telescope after Webb was contentious since he had been charged with complicity in the systematic termination of any personnel harboring homosexual tendencies. From the time of the idea until it was deployed and fully operational, it took 26 years. Considering that the James Webb Space Telescope was first proposed in 1996 with a 2007 launch date, its journey to completion was, to put it mildly, difficult. The expedition was postponed numerous times as a result of the mission's escalating expenditures. The design phase of the James Webb Space Telescope was completed in 2011, 4 years beyond the intended launch date, and work on its component pieces started. It was ultimately assembled and tested 5 years later. During testing in 2018, the telescope's solar screen tore, and an investigation discovered 344 potential single-point failures. In the years that followed, everything was tested again and answers were sought. In the end, the telescope will debut on December 25, 2021. The sensors on the James Webb Space Telescope enable it to take pictures of objects that are 100 times fainter than those that the Hubble Space Telescope could. A near-infrared camera and spectrograph. A combined mid-infrared camera and spectrograph. And a combination near-infrared camera, spectrograph, and guiding sensor, are the 4 scientific instruments of the James Webb Space Telescope. The James Webb Space Telescope now has an unmatched capacity to collect information about the cosmos and its origins thanks to these 4 instruments. Time travel is possible with the James Webb Space Telescope. The light that the earliest galaxies released when they were forming was in the visible spectrum. Light changes farther towards the infrared spectrum as it moves farther and longer. Like no other telescope before it, the telescope can record the light from the very first stars to develop as it takes pictures using infrared sensors. One of the most important capabilities of the James Webb Space Telescope is its capacity to peer back at the beginnings of the cosmos. Additionally, the James Webb Space Telescope is able to look straight through space dust clouds. Dust exists in space as well, and it interferes with conventional telescopes. This is particularly problematic since galaxies developing generate a lot of dust. The James Webb Space Telescope is capable of taking photos of galaxies forming that are superior than any other telescope because infrared light can pass through dust clouds more easily than light in the visible range can. To operate properly, the James Webb Space Telescope has to be kept at or below 370 degrees Fahrenheit 223 degrees Celsius. Infrared telescopes have the drawback of being rendered unusable by any kind of heat. Due to excessive heat interference, neither the Hubble Space Telescope nor infrared telescopes on Earth may be used. The temperature of space is really lower than that of the telescope, but only for objects that are not illuminated by the sun. In order to combat this, the James Webb Space Telescope features a sun shield consisting of 5 layers of reflective film, each as thin as a human hair. This shield reflects sunlight away from the telescope's very sensitive equipment. The telescope can only ever view 40% of the sky at once, since it must always be under the shade of the sun screen. The James Webb Space Telescope is located 1.5 million kilometers from Earth in a stable orbit. However, it is not orbiting the planet. It has been positioned in the Sun's orbit in a spot known as a Lagrange point because it must always be shielded from the Sun's light. A Lagrange point is a special place in space where two objects may be readily kept in close proximity to one another. At this scenario, it will be possible for the James Webb Space Telescope to virtually maintain an orbit around the Sun in a constant position with respect to Earth, with only sporadic motion corrections. The James Webb Space Telescope had to fold up like the most costly piece of origami in the world in order to fit inside its launch vehicle. The sun shield is approximately 14 by 22 meters, and the telescope's combined mirrors have a total diameter of 6.5 meters. Although there is a lot of room inside a rocket for a payload, this would never have a chance of fitting. The final solution, a telescope that folded in on itself, was both extremely clever and elegant. It took an amazing 2 weeks for it to gently unfurl, piece by piece, once it arrived at its destination before any of its instruments could be examined. The launch and deployment of the James Webb Space Telescope performed so well that the projected mission period was doubled. The James Webb Space Telescope requires very little fuel to remain stable in its orbit around the Sun. Conservative estimates of the fuel required to position and deploy the telescope gave the mission a lifespan of around 10 years. The James Webb Space Telescope's launch vehicle, Ariane 5, was so precise in its telescope positioning that substantially less fuel was necessary to deliver the telescope to its location. Because fuel is the only thing keeping the James Webb Space Telescope from working for much longer, this is a momentous accomplishment that NASA could only dream of. One of the most interesting aspects of the James Webb Space Telescope is the possibility that it may help future generations of scientists, astronomers, and ordinary people like you and me. While we stare up into the night sky, the James Webb Space Telescope will peer deep into it. We're as near to discovering the actual beginnings of our universe as we've ever been, and it's all owing to this fantastic piece of technology.